في هذا الإكزامبل عندنا مصفوفة اسمها A تساوي 3 7 1. هذا أول صف. 2 8 9. ثاني صف. 0 2 11. هذا الصف الثالث، أو بدل 11 نخليه 3. هذا هو الصف الثالث. انتر. هذه هي المصفوفة مال A اللي هي 3 في 3. So now I want to know what is the maximum value of A. So if I would ask you, can you write a code in MATLAB to find the maximum value of A? So if I want to solve this equation, I need to write firstly, I would assume max equal to A of 1 1. So this is the first step. I'm going to assume the first value of A is the maximum, and after that I will check each value in A with the first one to find which value is the maximum. So firstly, I assumed max equal to A of 1 1. Secondly, I need to open two counters. So the first counter for the number of the rows. So I'm going to use for I equal to 1 to rows number 3. So this is the base counter, because here 2-dimension matrix of 2 dimensions, so I need to build another counter. So I need to say for j equal to 1 to third column. So this is the second counter for the columns. After that, I need to put a statement, a comparison statement. So I need to say if A of ij greater than the max value, maximum value I assumed. If yes, then the maximum value equal to A of ij. So the maximum value is the current value of A. So maximum value equal to A of ij. If no, then compute another loop. So I need to write end, and then to look another loop, another end, and then end. So now I finished my code. So if I want to check which value is the maximum, just write max, then enter. So the maximum value is 9 in matrix of A. طيب عندنا هذه المصفوفة اسمها W تساوي 3 5 1 0. هذا الصف الأول. The second row 2 1 0 0 5 2 1 0 0. Okay. The third row is 58 1 7. So this is the third row, and the fourth one is this one. Close it, enter. So now I have a matrix called W. The size of W is 4 rows and 4 columns. My question now is, if I want to replace the values in the main diagonal of W from these numbers 3110 by 90, 90, 90, 90, and 90, what should I write here? So one method we can use, firstly I need to open a counter for the roses. So for I equal 1 to rows number 4. So this counter for the roses, enter. I have two-dimensional matrix, so I need another counter. So the next counter for the columns. So for j equal to 1 2 column number 4, this one. Now I need to specify only the main diagonal of W. So what is the feature of the values of W? The feature of the values of W for the main diagonal, the both of counters have the same value. For example, I equal to j for the first value of the main diagonal. The second value, I equal to j. Here I equal to and j equal to. Here I equal j also. 3 equal 3. And here I equal to j, 4 equal to 4. So now I need to write this condition. I would say if I equal to j, if yes, then W of I j equal to 90. For example, 90. and then and and then and enter. Now write W, then enter. So we can get the new matrix of W. The same, so the new matrix similar to the old one. However, the values of the main diagonal of the new W are 90, 90, 90, and 90 instead of the 3, 1, 1, and 0. So this is the first method we can write the new W. So now if I want to write another code using different method, so I can write, so this one W, so this the new W. Now I want to generate another W. So the new W similar to this one, however, the mean diagonal, the values of the mean diagonal to be 100 instead of 90s. So I can write for k equal from 1 to 3. So this counter for both of the rows and columns, I have, sorry, not 3, 4. I have 4 rows, so k from 1 to 4. And I have 4 columns, so k from 1 to 4. So in this method, I will use only one counter because I have a square matrix, 4 times 4. The second step is W of k and k, W of k and k equal to 100, for example. and then end. That's it. Then enter. Now write W, then enter. I can get the new matrix of W. So I got the values of 100 in each value in the mean diagonal of the new matrix of W with a simple code just for 3 steps. Now, if I want to replace only one value in the mean diagonal with another value, for example, replace this value by 80 instead of 100. So I need to write here A of, sorry, not A. What is the name of this matrix? W. W of, what is the location of this value? The location of this value 2, 2. So replace this value by 80. That's it. So now the new value of W of 2 has been replaced by 80 instead of 100. To check that, I need to write W to see the whole matrix of W, then enter. So look here, the value of W of 2 has been changed by 80. If I have A equal to 2 5 7 3 1 and then 0 5 3 9 1, another row 8 7 4 2 and 1, another row 4 1 0 8 2, another row 1 0 6 3 2. So we have a matrix called A. So A, the size of A is 5 times 5. Now, uh, if I want to change the values located under the main diagonal of A by 10 for each value. يعني عناصر القطر الرئيسي هذه 2 5 4 8 2. أريد أغير العناصر التي تقع تحت القطر الرئيسي بحيث كل عنصر نخليها تساوي 10. فكيف راح أولد هذه المصفوفة الجديدة؟ راح نقول for I equal to 1 until the fifth rows إلى الصف الخامس. وإذن هذا العداد for roses we need to open another counter. So the new counter is for j equal to 1 until the last column, number 5. So this is the second counter for the columns. Now I need to put a condition. This condition is if I is greater than j. Why I have put this condition? I put this condition because the feature of these numbers which located under the main diagonal, each location for these numbers, the counter of I is greater than the counter of j. The number of the rows أكبر من رقم العمود لكل رقم من ذي الأرقام. So I have put I greater than j. كل قيمة من ذن القيم في ال A هي A of ij. القيم اللي فوق القطر الرئيسي دائما ال j أكبر من ال I. قيم القطر الرئيسي ال I تساوي j. قيم اللي تحت القطر الرئيسي ال I أكبر من ال j. So أنا هسه أريد الأرقام اللي تحت القطر الرئيسي نبدلها بالعشرة، لكل رقم نخليه 10. فنجي إلى ميزة اللوكيشن لكل رقم إنه ال I greater than j. So if I greater than j, if yes, then A of I j equal to 10, for example. So replace each value by 10 for these numbers which located under the main diagonal of A. Then end and end and end. Now I need to check that. So print A, then enter. So look here. So we got 10 in each value under the main diagonal of A. So this one, the new A. Now if I want to replace the values located above the main diagonal, which each value, replace each value by 0. So I need to write the first counter for the roses. So for I equal to 1 to the 5th rose. So this counter for the roses, I need to have another counter because I have 2-dimension matrix. So for j equal to 1 to the last column is number 5. And then I need to put condition. If I less than j, or I can say j greater than I, also same. So if I less than j, why? Because the values above the main diagonal always I less than j. The roses less than the number of the roses less than the number of columns for the same location. So I less than j, yes, then A of ij equal to, for example, 0. Then end and end. Now we have a new matrix of A. So write A, then enter. So we got this is the new one. So there are zeros numbers above the main diagonal. Now if I want to change the values of the main diagonal by, for example, 50. So simply I can write just one counter for I equal from 1 to how many numbers in the main diagonal? 1, 2, 3, 4, 5, then 5. And then A of I comma I, because the number of the column for each value in the main diagonal equal to the number of the rows. رقم الصف نفسه هو رقم العمود لكل رقم من هذه الأرقام الواقعة في القطر الرئيسي. لهذا استخدمت كاونتر واحد فخليت هنا A of I equal to, for example, 50. and then end, and then write W, then enter. So I got 50, 50, 50, 50, and 50. Now I want to generate another matrix called B. So B, the size of B similar to the size of A. So the size of B 5 times 5. And each value in matrix of B equal to the same value in A but times 2 times 2. أنشئ مصفوفة B بحيث أنه حجم البي نفس حجم A اللي هي 5 ب5 وكل قيمة في البي هي تعادل القيمة المقابلة لها في الA مضروبة في 2 باستخدام الكنترول statements. So I need to write for I equal equal 1 to number of forces 5. For j equal 1 to 5. Now b of ij equal to a of ij times 3, for example. So the new b equal to the matrix of A times 2 and then end. Now A, we can got this one A and this one B. So this one B, each value in B equal to the same values of A but times 2. Now, so this one A, I want to generate another matrix called C. C, the size of C equal to the size of A, but each value in C equal to the same value of A but plus 3. أوجد قيمة ماتريكس C بحيث إنه السايز مال C نفس السايز مال A اللي هو 5 في 5 وكل قيمة في C هي نفس القيمة المقابلة لها في A ولكن زائدا 3. فراح نقول هنا for I تساوي من 1 إلى 5 the number of roses and then for j equal from 1 to 5 the number of columns in C of I j equal to A of I j plus 3 and 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 then write C. So we can got C same A but plus 3 for each value.